On to number 5. Find a new page in your answer booklet. Start number 5. And now let's read the problem. Consider the function f of x equals 96 over x squared plus kx. When I'm given a function like that, and I'm going to probably be referring back to it a lot, I tend to like to write it down in my workbook so that I can look at it, go back and reuse it, all that good stuff. Now, the part A says to find f prime. Now, I remember that it's not fun to find it when you have that variable in the denominator. So I'm going to rewrite f of x. So 96, when I rewrite that, that's x to the negative 2 plus kx. So part A says to find f prime. Finding that gradient function. Taking the derivative. Differentiating. Exponent comes down. Negative 2 times 96 is negative 192. X to the negative 3 plus 1 times k is k, x to the 0, nothing there. Now this is fine to leave, but I don't like working with that. I would rewrite it as x cubed plus k, personally. The graph of y equals f of x has a local minimum point at x equals 4. Minimum means it's the bottom, so like here, minimum. Remember, at a minimum, my slope is 0. So, at B, minimum means f prime of 4 equals 0. The derivative at 4 equals 0. And for some reason it says we can show that k equals 3. But we can. Let's plug that in. So if we know that f prime of 4 is 0, f prime is negative 192 over x cubed plus k, and we're going to set that equal to 0. Well, 4 cubed is 64. Let's add that over to the other side so it'd be positive. That'd be 192 over 64. Does that simplify any? 192 divided by 64. Oh, is 3. That's nice. Now, they told us that it was 3, but it's really nice that we could find it as well. C, find f of 2. Okay. Basic f. Go back to the original. 96 over x squared plus k times x. Oh, we know k now. So 96 divided by 4 plus 3 times 2. Notice that they do have more than one point here, so they want to see the substitution. Equals 30. So if they want to see the substitution, then the answer. F prime of 2 means I'm going to plug into f prime, which was negative 192 over x cubed plus k, which is now 3. Negative 192 divided by 8 plus 3 is negative 21. Find the equation of the normal to the graph at the point where x is 2. Okay, normal, perpendicular to tangent. So my slope would be the reciprocal, negative reciprocal, that's 1 over 21. And I need the point, it says, where x is 2. So the point where x is 2. I need the y value that goes with 2. Oh, they lead you to it. So, y. Now I could do, we'll do the y equals mx plus b. 30 equals 1 over 21 times x plus b, 2 over 21 plus b. So, I would do 30 minus 2 divided by 21, but I'm going to change it back to a fraction. 6/28 over 21 equals b. Now they are okay with you doing this on your paper, which I'm going to do. Y equals m is 1 over 21 x plus 6/28 over 21. I really don't want to leave it like this because that's not what they asked for. They asked for that weird form, and all the numbers have to be integers. How can I get rid of all those fractions that have 21 in the bottom? Oh, multiply both sides of the equation by 21. I'll get 21y. I'm going to put a line here so they know I'm continuing working over on this side. Equals 21 times 1 over 21 is 1x. This will be plus 6/28. Now I'm supposed to have everything on one side. I'll bring it all over there. Perfect. This, from getting from here to here, is 1 point. So if you didn't get there, that's not so bad. Point part F. Go sketch the graph. Sketch the graph. I might graph it on the graph paper. Now, if it says sketch, I don't have to be a perfectionist. Good. Not a perfectionist. So -10 to 100. Let's see. So maybe I start here as -10. 2, 3, 4. Okay. So I'll make this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I did it backwards. Oh my gosh. What do you do? Get another page. I'm going to flip it over just because we're doing it here. How did I do that? I need to go from -5 to 10. Oh, okay. So down here, I could do -5. I don't really want to scrunch it up that much. That's okay. Maybe we skip a little bit. -5, 0, 5, and 10. That works. This is my x-axis. And this is a sketch. So I'm going to make this be my y-axis. And I like what we were doing before. So -10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, on a sketch, we don't have to be perfectly accurate. But you do have to have the correct window. And I want to make sure I mark this y and x. So y equals, I need my f of x. So my f of x was fraction 96 x squared plus kx. Well, we found k, and actually they gave it to us. In part B, they gave us that. So I could have sketched this no matter what. I'm going to hit graph. Uh-oh. My window doesn't match. Make sure your window here matches the window in the problem. That's going to help when it comes time to sketch. Now, I might want to grab a couple of points. So I could go to my table, Or, if I get a trace, I can type in some points. So negative 5. That, oh, I can't get that. That's way below. What about, does it look like it's crossing at negative 3? That's negative 3, 5/3. Okay, so somewhere in here. So we got something going on here. This one's hard to tell. Let's try negative 1. Oh, that's at 93, so that's up here somewhere. So I know it's doing this. We have an asymptote there at 0, don't we? And this side looks like, let's try 0.3. 59, that's almost at 20, huh? Let's try at 5. Gosh, that's hard. It's hard to tell what's going on. But since this is a sketch, it's not that important that we're perfectionists. We're just sketching. Write down the coordinates of the point where the graph intersects the x-axis. I need to find that point. So, that sketch was F. So I would say that's on the graph. G, write down the x-intercept. I don't have to actually show how I found it. Good, because it's all calculator. That is a 0. Alright, so I know it was between negative 5 and negative 1. It's actually at negative 3.174802. That's the point where it crosses the x-axis. Let's see. Okay. H. Wait a minute. H says we got to find when we're decreasing. Well, this side's increasing. So decreasing is from here to this lowest point over in here. Now on my graph, it looks like it's around 5. But do we happen to know where the minimum actually occurs? So yeah, it occurs right at 4. So from 0 to 4. Or we could say 0 to 4 like this.